So today we are going to talk about how we can find the enthalpy change of a chemical reaction using the formation enthalpy data. So the last video we discussed how we can apply the Hess's law to find the enthalpy change of a chemical reaction. So today I'm going to tell you how we can use the formation enthalpy to find the enthalpy change of a chemical reaction. So the last video I told you that there are three main different types of standard enthalpy definition we use for chemical reaction in Edexcel in AS level. One is the formation enthalpy, the other one is combustion enthalpy, and the last one is the bond dissociation or the atomization enthalpy. So today we are going to do the first part of it, how we can use standard enthalpy of formation to find the enthalpy change of a chemical reaction. Now delta F H standard or delta H standard F, this is the symbol we use to represent standard enthalpy change of formation. So what is the standard enthalpy of formation? The standard enthalpy of formation is the enthalpy change when 1 mole of a compound is formed from its elements under standard conditions. 1 mole of compound is formed from its elements under standard conditions. For example, standard enthalpy change of formation of sodium carbonate Na2CO3. So how do we apply this one? So the formation enthalpy of sodium carbonate, we can only make 1 mole Na2CO3 solid state. We are going to form this one from the elements. So we have to have sodium solid, carbon solid, and oxygen gas. 2 here, so we put 2 in front of this. 1 carbons, 3 oxygen. So this should be 3 divided by 2 because we have 2 oxygen here. So total amount of oxygen should be 3. Now the formation enthalpy of an element of more stable state or more stable allotrope, we say is 0. When you talk about oxygen and ozone, ozone has a 0 formation enthalpy, whereas ozone O3 has a certain value. In diamond and graphite, diamond has the formation enthalpy value, whereas graphite has a formation enthalpy 0. So like that we have 0 enthalpy change for the element which is the most stable allotrope. But in your level, usually always consider formation enthalpy of an element is 0. So this is the formation enthalpy of sodium carbonate. So if I write another thing, formation enthalpy, delta H standard F of let's say calcium sulfate CaSO4. So that is the enthalpy change of formation. 1 mole of calcium sulfate solid, right? 1 mole of calcium sulfate from calcium solid, sulfur solid, oxygen O2 gas. 4 oxygens, so you should have 2. Now normally the standard state of sulfur is S8, but usually normally they don't expect you to remember those stuff, so writing with S is also fine. If they have given it, use S8, you have to use it as S8 because usually more stable physical state of sulfur, the formula of the sulfur molecule is S8, sulfur exists as S8. So this is how we write the formation enthalpy reaction. It is the enthalpy change when 1 mole of compound is formed from its elements under standard conditions. So now let's see how we use this formation enthalpy data to calculate the enthalpy change of a chemical reaction. Now the data is the most important thing you have to look at when you start the question. What kind of data you are given? If the formation enthalpy data is given, we have to use that formation enthalpy data to do the chemical reaction. For example, we'll see. So this is the formation enthalpy data, the right reaction. Let's start the question. Let's see how we can do the question if the formation enthalpy data is given. If the formation enthalpy data is given, we can use either formula, or we can use a Hess cycle. So most commonly they ask us to construct a Hess cycle. If you know how to construct a cycle, you can use the idea behind the Hess cycle to do or derive an equation. You can memorize it and you can do the calculation accordingly. So first we will see how we can construct the Hess cycle if you are given the formation enthalpy data. So remember, we are talking about the formation enthalpy, nothing else. So if the formation enthalpy data is given, first you have to do is you have to write the chemical reaction. So let's assume this is a reaction you are given. I'm going to find the enthalpy change of this chemical reaction. Sodium hydrogen carbonate, thermally decomposed to produce sodium carbonate Na2CO3 plus carbon dioxide and H2O. To balance this H2. So let's say you are given the formation enthalpy data F standard of NaHCO3. These are the data you are given. Data formation expanded Na2CO3. Formation enthalpy of carbon dioxide. Formation enthalpy of H2O. This is minus 286 kilojoule per mole. 396 normally, or 391. 394 minus 394 kilojoule per mole. Sodium carbonate value is minus 951 kilojoule per mole, and sodium hydrogen carbonate is minus 1131 kilojoule per mole. Right, so these are the enthalpy changes you are given. So we'll see how we can use this value to construct the enthalpy cycle. So this is the data you are given. So this is how we construct the cycle. First we'll write the balance reaction on top. So I'll write it over here now. So it is NaHCO3, sodium hydrogen carbonate solid, gives you Na2CO3, sodium carbonate plus carbon dioxide and H2. It is better if you can balance this with the physical states, but sometimes they might say no need of the physical state. So write the reaction on top, that's the first step. Then you have to write the required elements at the bottom, elements under standard conditions. So you have to have sodium solid, hydrogen gas, carbon solid or graphite, and oxygen gas. Elements you can write in any order, that doesn't matter. So 2 sodium, 2 here, 2 hydrogen is fine, 2 carbon, put 2 here, 2 into 3, 6 oxygen, so we have to have 3 or 2 here. That's the second step. First step, write the reaction on top. Second step, write the balanced elements at the bottom, or you can write the elements and balance it. Then you have to put the arrows from elements to the compounds, because formation enthalpy means you are forming compounds from elements. So it's like this and then like that. Now this doesn't mean that hydrogen gives you NaHCO3 or hydrogen gives you CO2. This whole idea is all the elements present here are using to produce NaHCO3, and all the elements here are using to produce sodium carbonate, carbon dioxide, and H2O. We just write the elements at the bottom and we just draw 2 arrows like that. So this is something similar that I just used ABC. The previous lesson we discussed how you apply the Hess law. So this is like ABC. In this case, this is A, this is B, and this entire thing, this is C. Okay, so this is what we apply there. Now I have given you the values. What is the last step? We have to apply the Hess's law. So this is what we have to find, delta RH. Right? This is, I just put delta H1 and this is as delta H2. So how do you apply this then? According to the Hess's law, delta H1 plus this one and this one is equal to this one. Delta H1 plus delta RH standard equals to delta H2. I'm erasing this A and B now. So what is delta H1? Formation of NaHCO3. Now formation enthalpy depends, it suggests formation of 1 mole. Here you have 2 moles. Then you have to multiply this by 2. 2 into NaHCO3, which is 1131 minus 1131 plus delta RH. Delta RH is the one we have to find. I'll just put X for that, equals delta H2, sodium carbonate value. Sodium carbonate is minus 951 plus carbon dioxide minus 394 plus H2O minus 286. So you can subject X and get the value. That is how we find the enthalpy change of a chemical reaction using the formation enthalpy data. Right? The reaction on top, elements at the bottom, balance it, arrows from elements to the compounds. That's how we do. So summation using the calculation, we can find the value of this. So the value of this one would be, right, we'll calculate the value. So this is the enthalpy change of this chemical reaction. So when you do the calculation, you get plus 631 kilojoule per mole. So it should be, because this is a thermal decomposition reaction, so it will have a positive value. Now this is how we do. So this is how we construct the enthalpy cycle and calculate using the enthalpy cycle. If you have to do this by yourself in AS chemistry paper, this will be something like 4 to 5 mark question. Now for the MCQs, it's hard to use all these steps at once. So we use a formula. So we'll see how we can derive a formula from this reaction or this Hess cycle. Now if we want to find delta RH, so what does this mean? Delta RH equals delta H2, that means this side minus, we go to the other side, delta H1. So it's indirectly saying delta RH equals the enthalpy of the formation of delta H2, which means the product side minus delta H1. So we can derive a formula like this for the calculations. The formula we derive is something this. So if I erase everything and write, we can derive the formula. The enthalpy change of chemical reaction is equal summation. This is sigma summation. Summation enthalpy of formation of products minus summation formation enthalpy of reactants. So products minus reactants also give the same answer. So this is very easy way to find out the enthalpy change of a chemical reaction, unless if you ask to do the Hess cycle. There are questions that they ask you to construct the Hess cycle. If you are not asked, then you can use this. Right. So we'll do another example and see how we can find the enthalpy change. So in that example, I'm going to do it both ways. So example number 2 is, let's assume we are going to find the enthalpy change of a cracking reaction. So let's say C8 octane, C8H18 undergo cracking, produce C4H10 plus 2 into C2H4. So this is a reaction you have given. So the formation enthalpy data is given. Formation enthalpy of C8H18 is the one they asked me, see. And I don't know the value, I am writing this, I don't know exact value, I say that this is equal to 150 kilojoule. So they are given the enthalpy change of the reaction. Formation enthalpy we have to find out C8H18, I don't know exactly the value, we'll see. C4H10, C4H10 value. So formation enthalpy of this one is around minus 127 kilojoule per mole. And the formation enthalpy of C2H4 equals positive value, plus 52 kilojoule per mole. So these are the data you are given. Let's see how we can find the enthalpy change of formation of C8H8 using the Hess cycle. Again, what we are doing is, write the reaction on top. We have written elements at the bottom. We have to have carbon solid and hydrogen gas. 8 carbon, 18 hydrogen, so 9. That's it. Arrows from elements to compounds. Then what? If this is delta H1, this is delta H2, right? So delta H1 plus 150 equals delta H2. Now what we need the formation enthalpy of C8H18. So we need that one. So delta H1 equals delta H2 minus 150. So delta H2 is C4H10. C4H10 value is minus 127 plus 2 into C2H4. 2 into C2H4 value is plus 52 minus 150. So you can get the formation enthalpy of the C8H18 using that. So minus 127 plus 2 into 52 minus 150. So minus 170. That is the enthalpy change of formation of CH-H18. So if I apply the equation, so I'll erase everything here. Enthalpy change of reaction is 150. That is equal to summation of products. So products have 2 into C2H4. So 2 into plus 52 plus minus formation enthalpy of C4H10 minus 127. Products minus reactants. That is what they are asking. Only one reactant is there. So 150 equals 104 minus 127 minus x. So x would be the opposite side. 104 minus 127 minus 170 minus 170 kilojoule per mole. So that is the way you can do it. This is products minus reactants. So we can use this one for the MCQs. So that's a similar way. That's everything that we have to know. So that's how we use the formation enthalpy data to construct the Hess cycle and how we can calculate using the equation. But remember, this equation and the way we describe how to construct the Hess cycle always depends on the data you are given. In this particular case, we discussed how we can construct the Hess cycle if the formation enthalpy data is given. If the formation enthalpy data is not given, if anything else is given, you can't use this method. This is how we do the calculation if the formation enthalpy data is given. So the next video, I'll discuss how we can construct the Hess cycle and how we can find the enthalpy change if the combustion enthalpy data is given. So that's it. That's how we do the calculation using Hess law and the formation enthalpy data. Thanks for watching.